Hello everyone, my name is Shyam Chauhan and today we are going to discuss exercise 1.1 question number 5, 6 and 7. Question number 5 says that check whether 6 raised to n where n is a natural number ends with digit 0 or not. We have solved the similar example, that is, does 4 raised to n ends with digit 0 or not. Now let us solve this example, that is, does 6 raised to n ends with digit 0 or not. So for number to end with digit 0, it must have 2 into 5 in prime factorization. Let's say for example 40, prime factorization of 40 is 2 into 2 into 2 into 5, and if we see there is 2 into 5 in prime factorization, for 6 raised to n to end with digit 0, it must have 2 into 5 in its prime factorization. If we do the prime factorization of 6 raised to n, that is equals to prime factorization of 6 is 2 into 3 raised to power n. We can give the powers separate, that is 2 raised to n into 3 raised to n. But prime factorization of 6 raised to n does not contain 5. Hence 6 raised to n never ends with digit 0. For any natural number n. Now let us solve sixth question. Question number 6 says that we have to prove 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 2 1 plus 5 are composite numbers. To prove any number as composite number, let's say we want to prove that 6 is a composite number, so we have to just divide this number into two numbers such that both the numbers are other than 1. That is, for example, like if I want to prove 6 as composite number, I will say that this is a product of two prime numbers and hence 6 is composite. If I want to say that 12 is a composite number, I will just say that 12 is product of two prime numbers, that is 12 equals to 2 into 2 into 3. It is a product of two or more than two prime numbers, hence 12 is composite. If we take an example of prime number, that is 7, 7 is a product of 7, that is number itself, into 1 and no other prime numbers. Hence, if I want to prove that this number is a prime number, I just have to prove that this number is a product of two different prime numbers. So if I take 13 in common, I will get 7 into 11 plus I have taken 13 common, so I will get 1 here. That is equals to 13 into 77 plus 1, that is equals to 13 into 78. So I can say that 13 into 78, I can write 13 into 78 equals to 13 into 2 into 3 into 13. So this is the product of more than two prime numbers, hence the given number is composite. If I check the next number, that is equals to, I can take 5 in common from both, that is equals to 7 into 6 into 4 3 2 into 1 plus I have taken 5 in common, so remaining is 1, that is equals to 5 into the product equals to 1008 plus 1, that is equals to 5 into 1009, where 5 and 1009 both are prime numbers, but the product of two prime numbers is a composite number. We can see here product of two prime numbers, 2 into 3 gives a composite number. Product of two prime number is a composite number, hence I can say that given number is composite. If I write here the logic, that is product of two or more than two prime numbers is composite number. Now let's solve the last question. Question number 7. Question number 7 says that there is a circular path around a sports field. Sonia takes 18 minutes to complete a circular round and Ravi takes 12 minutes. Suppose they both start at the same point at the same time and goes in the same direction. After how many minutes will they meet again at the starting point? So there is a circular field and from a given point both the starts and Ravi takes 12 minutes and Sonia takes 18 minutes to complete. Let us understand this question with one simple example, that if we take a field and Ravi starts the round, that is Ravi starts from this point, Ravi will come to this point again after 12 minutes, then 24 minutes, then 36 minutes, then 48 minutes, and so on. If we see these numbers, then we can see that all the numbers are divisible by 12. That is, all the numbers are divisible by 12, or I can say that 24, 12, 24, 36 and so on are multiple of 12. So if Ravi starts to run, he will come at the same point after the multiple of 12. So if both Ravi and Sonia starts to run, he will come at the same point after the multiple of 12 and 18 for the first time. That is, we have to find the multiple, that is LCM, least common multiple, after which they will meet at the first time. So we have to find the LCM of 12 and 18, that is equals to 12 and 18. 12 equals to 2 into 2 into 3, and 18 equals to 2 into 3 into 3. So LCM equals to 2 into 3 into 2 equals into 3, that is equals to 36. So we can write Ravi and Sonia We'll meet after 36 minutes at the starting point. In next lecture, we will cover topic number 1.3, revisiting the irrational numbers. Thank you.